Hello, welcome to the session. Today we will be talking about the concept of accessibility, connectivity, and network analysis. Under network analysis, we will be talking about the various indices of network. So let's start with what is accessibility. Accessibility basically means how accessible a place is. For example, I say there is a mountainous terrain. So my accessibility of reaching the top of the mountain would be poor as compared to reaching the bottom of the mountain. So that is what is meant by the word accessibility. So accessibility is basically the ease of reaching any location. So if a location is highly accessible, what does it mean? A highly accessible location means that you can reach there very quickly, or it's easier to reach to that location. Now, accessibility is basically dependent on the location, where it is located, and the distance from the major centers. So if it is very close to the major center, the accessibility is good. If it is far from the major center, the accessibility is poor. Now, the various forms of accessibility are topological accessibility. Topological accessibility means where I am trying to measure the accessibility and it is significant to a specific element of transportation. For example, I say I am only talking about road connectivity in a region. Okay, so that is kind of topological accessibility. Then I can say geographical accessibility, as we discussed in the above example. So if it is a hilly terrain, the accessibility would be difficult. If it is a plain area, the accessibility would be very easy. And then we talk about the potential accessibility. What is potential accessibility? Potential accessibility basically means if I have to reach a point A from point B, okay, then what would be the travel time along with the distance covered and the weight of different attributes. So this potential accessibility is based on two parameters. The first is emissiveness. Emissiveness means what is the ability to leave a location. Okay, and next is attractiveness. What are the factors that causes or pull the people to that location? Okay, so emissivity is the push factor from a location, basically in simple terms, and attractiveness is the pull factor to that location. For example, if I say MNC is coming up in this region, okay, it will drive a lot of people looking for jobs, looking for employment. Okay, so that would be a kind of attractiveness. And on the other hand, there can be emissiveness, where you can say the nearby areas are developing in mining sector. So people from this village will try to move out to the nearby settlements. Okay? So these are the kind of accessibility we talk about. Now the next concept that we would be discussing today is connectivity. Connectivity tries to explain how well place A is connected to place B. Okay, so it's connected through road, through rail, how many roads, how many intersections, what is the traffic flow. So these all are understood under the concept of connectivity. So under connectivity, we try to understand connections between each node. So every node's connection to another node would be a kind of connectivity. So to understand connectivity, let's look at this diagram. Okay, so in this diagram, you have the various nodes here. Okay, so these are the nodes that we would be talking, and these are the edges or the links that we discussed previously in the graph theory concept. So these are the edges or the links that are connecting the various nodes. Okay, so those marked in purple are all the nodes. Now what we are telling to understand here is, for example, node 1 is connected to 3, but node 1 is not connected to node 2. So this is the first order matrix. Okay, so node 1 is connected to node 3. Okay, so node 1 is connected to node 3. So there I try to mark 1. Okay, so node 1 is not connected to node 2. So I mark 0 here. And similarly, I fill up the matrix here. and then I do the total of the matrix. So this is the sum. So I add all these values here and try to fill up the values here. So this is the first order matrix. So anything which is connected would have a value of 1 in the first order matrix, and unconnected parameters will have a value of 0 in the first order matrix. Okay. Now all these rows that we are talking about explain the origin, and all these columns here explain the destination. Okay. So originating from 1 to 3, I have one connection, but originating from 3 and ending on to 1 is the destination. Okay. So this is what we try to understand by means of connectivity. Now let's move on to the second order matrix. So this is the second order matrix. Now what I am trying to do, let's take the example of 4 or 4 with 10. Okay. So 4 with 10 shows to 2 and 4 with 4 shows you 4. Okay. So in second order matrix, what I am trying to do, this is 4. So I can say this is 4. I can go to 3 and come back. So this is 1. I can go to 2 and come back. So this is 1. I can go to N8 and come back. So this is 1. I can go to N7 and come back. So this is 1. So relation of node 4 to node 4 is attained by 1, 2, 3, 4. So that is 4. Okay. And node 4 to node 10. So node 4 to node 10, there are only two ways. Either I can go through this path or through this path. So there are two unique ways to reach it. So I will mark here 2. So under second order, we are talking about one more addition of node intermittently and understanding the number of connections. Okay. So in first order, there is just a connection of one node to another. In second order, there is connection of one node to another with an intermittent node. And similarly, in third order, there would be 2 intermittent, fourth order, there would be 3 intermittent, and fifth order, there would be 4 intermittent nodes. Okay, so this is how the hierarchy of nodes work. Now, so this is attained by matrix multiplication, and when we are trying to find the T index or the total index for the accessibility, it would be the matrix addition for all the higher order nodes. So C1 plus C2 plus C3 plus C4 plus C5. Now for any network, we need to find out the diameter. Now let's understand what is the diameter. So diameter of a network is the maximum steps I am trying to move to reach to another node. Okay, so in this example, let's understand it very clearly. So for example, if I am trying to move from node 1 to node 3, I can move through one path. Okay, if I am moving from node 1 to node 13, there can be 1, 2, 3, 4 and 5. So there would be 5 steps I would be taking from node 1, N1 to N3, then N4, N8, N10 and N13. So this is N4. Okay, so there are 5 steps. Okay, similarly, if I want to move from N2 to N9, how many steps would be there? 1, 2 and 3. Okay, so of these, I'll try to find out for all possible nodes, and then I'll try to find out the maximum number of steps. So for this network, let's say the diameter of this network would be 5, because to move from any extreme point to another extreme point, the maximum number of steps required are 5. If I try to move from N1 to N13, it's 5. If I try to move from N1 to N12, it's again 5. So you have 1, 2, 3, 4 and 5. Okay, so these are the, so what is diameter is now clear. It's a kind of maximum steps you are taking to move from one node to the other node by the shortest route. I cannot say I am going the whole way around about and then reaching N13. So I am doing so many steps. Okay, so I am taking the shortest possible routes, but under the shortest possible route, what I am trying to do is I am trying to find out the maximum number of steps used in whole of the network. So that is basically what is the diameter. Now, since we have talked about the concept of accessibility and the concept of connectivity, we'll move forward to the concept of network analysis. So under network analysis, we study things basically classified into two criteria: non-ratio analysis and ratio analysis. The first component of non-ratio analysis is the diameter that we already have understood how to calculate. Then the second concept under non-ratio analysis, first is the diameter. The second is cyclomatic index. What is cyclomatic index is basically denoted by mu, and it is the number of edges minus the vertices plus the number of subgraphs. So it talks about the level of development and complexity in a region, and it's kind of a simple cycle that is being explained under this process. The next thing we would be understanding under non-ratio. So these are all for non-ratio. The next is road density. How do we calculate the road density? So road density is basically how long the road is, so the length of the road per unit area. That's what is the road density. So these are basically the three concepts which are the part of network property. So these are property of network. Now there are each single element in the network. So we'll be talking about the properties of the single elements in the network. So under the single elements, we first talk about the degree of circuitry. So circuit is basically, for example, there are 4 points here. So this is the circuit I can draw. There is one circuit and two circuits, okay, with 4 nodes. So degree of circuitry is the relative location of the network that you are trying to find out. Then you try to find out the dispersion, how they are dispersed into the whole region. So this is the whole region, for example, I say, and here is the location of transport points. So I can say this is the dispersion. Here they are highly concentrated, and here they are dispersed. And the next thing I talk about in the non-ratio analysis under single element is the associated numbers. So associated numbers is the maximum distance from vertex 1 to vertex 2. So there are 2 vertex, and what is the maximum distance between the 2 vertex would be the associated number. So these are all the kinds of what we say the non-ratio methods of network analysis. Now we'll move on to the ratio analysis under network. So ratio analysis is broadly classified into 3 categories. So first is between the elements of the network. Okay. So the 3 things we would be considering here is alpha, beta, and gamma. The next thing is between the whole network, okay, and the individual element. So we would be considering eta and pi here. And the last is between the whole network and remaining elements. So we will be talking about iota and theta. Okay, so now let's discuss one by one. So first we will be covering these 4 iota. So under the first, that is the Eta Index, what we try to understand here is basically the concept of average length per link. So what is the average length per link is the Eta Index. So for example, there are 2 nodes and I add one more node in between. What would happen is my average length would decrease. Okay, since my average length would decrease, my Eta Index would also decrease. So if I am decreasing the average length, my Eta Index would also decrease. So this is what is the first we have discussed on the Eta Index, average length per link that we are trying to find out in a network. Then what is pi? So pi is the total length of the graph. Okay. Under pi, we would be talking about the total length of the graph divided by the diameter of the graph. Okay. So for example, let's move on to the same case here, this diagram. If I say Each edge is 2 kilometers long. Okay, and I calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 edges. So there are 13 edges. So the total length would be 13 into 2, that is 26. Okay, so that is the total length. And then you have the diameter. So the diameter we calculated for this case was 5. So diameter is equal to 5, and the length of each diameter is 2. So the total length of the diameter would be 5 into 2. So that's 10. In this case, the pi index would be total length by diameter. So it would be 26 by 10. So it's 2.6. Okay. So in this case, we understand if the pi index is high, okay, the network is more complex and also more developed. Okay, so that is the pi index. The next index we would be covering today is the theta index. Theta index is basically the function of node. So we would be talking about one single node here. So it's the average amount of traffic per intersection. So from each point, how much traffic is flowing, that would be explained under the theta index. So for example, let's move on to the same case here. So if I say the total volume of traffic here is say 100, okay, and there are 13 nodes. So what would be the traffic for each intersection? It would be 100 by 30, okay, for those areas per node per day, okay. So here is how we are calculating the theta index. So average flow of traffic per vertex. Our aim is to find out how much traffic is flowing per vertex every day. Per vertex or per node per day. Okay, so that's the theta index. The next is the IOTA index. Now IOTA index is a unique index that we need to understand because IOTA index talks about weight. Now what is the weight in this sense? Now some people confuse it with how much traffic is flowing through this region, but it's not basically the traffic. IOTA index talks about the total length and the total traffic flow. So you have the total length divided by the total traffic flow. Now how do you calculate the total traffic flow? Total length in this case was 26. Now what is the total the total traffic flow or the total weight? Now how do we calculate the weight? Those which are at the end would have a value of 1. So this is 1, 1, 1, 1, 1, 1, 1, 1. So you have 8 things which have a value of 1. So 1 into 8, okay. Then plus this node, this node, this node, and this node are connected to 4 points. So it's a kind of crossing. So you have 1, 2, 3, 4. So anything which is connected to 4, the value will double in terms of weight. Okay, so it's 4 into 2 here. Then you have plus 4 into 2 plus 4 into 2 plus 4 into 2 for each of these nodes. Okay, and for N3 you have 1 and 2 ways. So again, it's more than 1, so you are doubling that. So how do we calculate the weight in case of IOTA? So in case of IOTA, the total traffic flow or weight is calculated as, it's a simple way. So you have the summation of each node. So you are trying to summate each node, okay? And those which nodes are having a value of more than 1, you will be multiplying it by 2. Okay, so if the node is having a value of 1, you will let it remain 1. But if the node is connected to 4 other nodes, okay, so it is 4. In that case, you will double it out. So the weight would be 8. Okay, so let's say for a very simple diagram here, I have 1. Okay, so this is my diagram here. Now here, this, and this. All of them will have a value of 1. So I'll be doing 1 plus 1 plus 1 plus 1 6 times. 1, 2, 3, 4, 5 plus 6. Okay, and then these two would have a value of 4 because they have 4 roads that are being connected. So I'll double that, 4 into 2 plus 4 into 2. So my total weight in this case would be 22. And then I'll have a total length. Say for my example, my total length is 80. Okay, so the IOTA index would be 80 by 22. And I get a value of 3.6, for example. And in another case, I have a value of 3.2. Okay, so what is important here to understand is that the lower the value, the more efficient the network. So this network would be much more efficient as compared to this network. So if my IOTA index is less, okay, the system would be more efficient. Okay. So this is how we understand the Eta index. Then we talked about the Pi index, Theta index, and the IOTA index. The next is the Beta index. So now next, under the elements of network analysis, we have alpha, beta, and gamma. So let's try to understand here and move on to a separate page. Okay. So let's try to understand the concept of beta index. So if I talk about beta index is basically edges per vertices or nodes. So if I have, in that case, say 12 edges and 5 nodes, okay, and 15 nodes, okay. So that would be my beta index. For example, okay, in this case, I have 4 nodes or vertices and 5 edges. So it's 5 by 4. Okay, so that is the beta index I'm trying to calculate here. The next thing, so if the network is complex, the beta value would increase. So if in any case, if I say the beta value is greater than 1, that means the network is getting more and more complex. So as and when the beta index increases, the complexity of network also tends to increase. So that is what is the beta index. The next is, we'll try to understand, is the alpha index. Now what is alpha index? Understanding the concept of alpha index and gamma index is very important. Okay, so alpha index basically tries to understand the number of cycles in a graph as compared to the maximum number of cycles. So number of cycles divided by maximum number of simple or basic cycles. And what is gamma index? Under gamma index, what I try to understand is number of links as compared to the maximum number of links. Okay, so let's first understand the gamma index. That would make the things easier for us. Okay, so gamma index in case of planar graph and non-planar graph. Now, what is the difference between planar graph and non-planar graph? We have already done this in the concept of graph theory. Let's revise it again. So the planar graph here means, for example, I have 4 points. Okay, I have 4 nodes and I'm connecting those nodes. I can connect it through these paths, and this is another path that I can do. What I can do is I can draw another line here, but as soon as I draw another line here, what happens is one more node pops up. So my node increases from 4 to 5, and that is not the reality what I want to attain. So under a planar graph, there cannot be intersection of any edges. So in this case, this would be a planar graph. If I want to move from this point to this point, I can go for an overbridge or an underbridge, which is not crossing that intersection, and that would go under the case of non-planar graph. Okay, so under planar graph, what we try to understand is just edges without intersection. So that is what is planar graph. Now let's have a quick understanding about What is gamma index? So as we said, number of links divided by the maximum number of links. So the value should lie between 0 to 1 for gamma index. If the value is 1, that means it is completely connected graph. Okay. So in case of planar graph, the value of gamma index would be the number of edges divided by 3 nodes minus 2. Okay. Now, how is this 3 nodes minus 2 coming up? So when I'm taking the example of 4, this is what is the ideal example that could be established. So there are 4 nodes minus 2 nodes, 4 nodes minus 2, so the value would be 6 here. So there would be 6 possible links in this case. Okay, so this is the maximum number of links that can be achieved, and then we are talking about the number of edges. So you have 6 by 6, so the value would be 1. So it is a kind of completely connected graph. This for the planar case, but what would happen in the non-planar case? Non-planar case is much more simpler. So it would be n minus 1 by 2. So if I have 3 edges here, I'm connecting this. Okay, with every edge that I add, my next number would be n minus 1 by 2. Okay, so this is a case of non-planar graph. So this would be the case in planar graph, and this would be the equation in non-planar graph. Now, since we know this, I can easily calculate the alpha index. Now, what is alpha index? Alpha index we talked about is the number of basic cycles divided by the maximum number of basic cycles. Now, if I am taking the same example of 4 nodes, what is the number of basic cycles here? So this is the first basic cycle, and this is the second basic cycle. Okay, so the number of basic cycle here would be 2. But if I try to say, if I visualize this, I can say I have one cycle which is this. Cycle is basically something which starts and ends at the same point, which we have already talked about in the graph theory. So if I talk about the cycle here, I can say this is one cycle, this is second cycle, and this complete is the third cycle. But we are talking about only the basic cycles in case of alpha index, which is very important. So here, what would be the number of basic cycles? Basic cycles are those which do not include union of any 2 cycles. Okay, so I cannot unite 1 and 2 and say this would be another cycle. So here, how many basic cycles would be there? Just 2. And what would be the maximum number of cycles? Again, we will try to pick out from this case. Okay, so the maximum number of cycles here would be 1, 2, and 3. And now how we are comparing this? So it's the case of 4 nodes only. So you have 4 nodes. If I arrange in this fashion, I can have 2 basic cycles. Okay, but if I arrange the same 4 nodes in this manner, I can have 3 basic cycles. So these are my maximum number of basic cycles. Now, if I try to depict the equations for same alpha index for planar and non-planar again, it would be very simple. So the planar alpha index would be the number of basic cycles, okay, that we calculated divided by the maximum number of cycles, and here it was E minus n minus 1, okay, and this E or edges, maximum number of edges 3n minus 2. So if I substitute here 3n minus 2 minus n minus 1, I get the value 2n minus 5. Okay, so the number of so the alpha index for a planar graph would be L minus n plus 1 divided by 2n minus 5. Now if I try to put the values here and solve, I would get 3. So the maximum number of basic cycles, if I put n as 4, my value here would be 2 into 4, that is 8, minus 5, that's 3. So my maximum number of basic cycles can be 3. So if I have 4 points, I can arrange those 4 points in such a way that I attain maximally 3 simple cycles. So these are the 3 simple cycles that I attain, 1, 2, and 3. So alpha index for planar case would be L minus n plus 1 divided by 2n minus 5. Okay. And then for non-planar, it would be the same that we talked about, minus n minus 1 here. So it's e minus n minus 1. So this would again we will be considering here. So for non-planar, the alpha index would be again the value e minus v divided e minus the nodes divided by n minus 1 by 2 minus n minus 1. So this would be the alpha index for non-planar case, and we have derived this alpha index from the concept here. So now just to revise the concept of alpha and gamma index once again, if I am trying to find out the maximum number of cycles and maximum number of links, I try a simple case, okay? And when I am trying to find out the maximum number of links for case of alpha and for case of gamma and maximum number of cycles for case of alpha, I'll try to arrange these 4 nodes in an ideal fashion, and I'll get the maximum number of nodes here, maximum number of links, and also maximum number of cycles in this case. Okay, so this is very important. So alpha index and gamma index, the major differences. Under gamma index, we are talking about number of basic cycles divided by maximum number of basic cycles, and under gamma index, we are talking about number of links divided by maximum number of links. So with this, we cover the concept of network analysis, which is highly based on the concept that we have discussed in the graph theory. We have talked about how different indices are calculated and with suitable examples. We have also talked about the concept of accessibility and connectivity along with connectivity metrics. So hope this class was clear. We would be talking about more concepts of advanced geography in further sessions. Have a good day.